Hi folks, welcome to the last part of 5.1, the section called angle. So this is the part we didn't get to in class. It's the length of an arc and the area of a sector. So if we have an angle in a circle, here are two things that we can find. First of all, we can find the length of an arc. And what I mean by length of an arc is just this. That if we have a given angle inside of our circle, okay, and we call these central angles, and they're called central angles because they have their vertex at the center. But if we have a central angle, however big it is, the arc that sweeps out on the edge of the circle, this part, okay, then if we have a bigger angle, we'll have a bigger arc. If we have a smaller angle, we'll have a smaller arc, okay? So the length of the arc is nothing more than how much of the edge of the circle do we have given an angle, all right? We can think about this kind of like the pizza crust, okay? So how long is the crust on your given pizza slice? Okay, and so we know that if we have a larger slice, we're likely to have more crust than if we have a smaller slice. Now, the other thing we can find if we have an angle in a circle is we can find something called the area of a sector. And so this area of the sector is really saying, what's the area of this slice? So when they say area of a sector, they really also mean the area of a slice of pizza, okay? And this one has a formula, A equals 1/2 times theta times r squared, okay? Where r is nothing more than the radius, and theta is the angle. But I want us to be really careful here. It's the angle in radians, okay? So in order to use this formula, we need to make sure that we have an angle measure in radians and we have the radius. Now let's go back to the length of an arc and talk about that formula. So when we talk about arc, we use this lowercase letter s. And so s equals the radius times the angle. Okay, that's a much more straightforward formula, but basically we have the radius times the angle in radians, and that will give us the length of the arc that goes with the angle, okay? So you'll notice in both these cases that in order to use the formula, we have to have the radius, not the diameter, but the radius, and we need to have the angle measured in radians, not degree. Okay. So let's walk through one example of each and see how that goes. Okay, so for example 6, it says find the arc length of a circle with a diameter of 8 meters subtended by a central angle of 220 degrees. We have a lot of fancy words in here, but as I'm reading, I'm going to start with the arc length. And as soon as I see arc length, I'm going to write down the formula that we have for arc length. S equals R theta. Now, as soon as I see the R, I know I'm going to need to have the diameter. Take this diameter of 8 meters, and we're going to use that to get the radius of 4 meters. So all we do is we take the diameter, we cut it in half, okay? This is maybe one of the easiest ways to make a problem more complicated, is to give you the diameter, hope you just pick the number, when secretly all you needed to do was divide by 2 to get the radius, okay? So we're not going to fall for that trick. We already know I don't want the diameter of 8 meters, I want a radius of 4 meters. Now, when it says subtended by a central angle, all that means is we have a central angle that is 220 degrees. So I'm going to draw a diagram of a circle. Richard, be jealous. And we're going to draw the angle that is 220 degrees in standard form. So here's my positive x-axis direction. 220 degrees means it's a little bit more than halfway around the circle. So it's going to be like somewhere here. And the angle I'm looking at is this angle right here. Okay. Now they tell me this is 220 degrees. And again, I'm like, I'm not going to fall for this. I don't want to use that number. I need to change that degrees to radians. Okay. So we want to change that to radians. Now, once we change it to radians, what are we finding? Well, we're finding out how long this piece of the circle is. Okay. So again, we know that the radius equals 4, and we have this angle of 220 degrees, but we need that in radians. So let's change 220 degrees to radians. And we're going to use that formula we learned earlier in class. That is the degrees over 180 equals the angle in radians over pi, okay? And let's see what we can reduce. So when we reduce the left-hand side, we can make that 22 over 18, and we can reduce that more to be 11 over 9, okay? So really I have 11 over 9 equals theta over pi. And the last thing I need to do to finish my angle conversion is multiply both sides by pi. So I will get theta equals 11 pi over 9, okay? This is what goes in for theta, and 4 is what goes in for r. So we get S equals 4 times 11 pi over 9. And if we multiply that out, we'll get an arc length of 44 pi over 9 meters. Okay, so that corresponds to the edge of that circle. If the radius of the circle was 4 meters and the central angle was 220 degrees, then the arc length would be 44 pi over 9 meters long. Okay? All right, now let's take a look at an example on the area of a sector. And so when we look at the area of a sector, what we're looking for is not how much crust there is, but what's the area of the slice, okay? We could almost think about it like how much cheese is on that pizza or how much sauce is on that pizza, okay? And so as soon as I see the area of a sector, I'm going to go ahead and write down the formula that I need. Area equals 1/2 theta r squared. Okay, so let's read the rest of the problem now. Find the area of a sector of a circle with a central angle of 60 and a radius of 5 centimeters. Okay, so let's see what this looks like in a picture. We're going to draw our imperfect but soon to be perfect circle. And we're going to have our initial side, and I want to have the terminal side around 60 degrees. So I know this is 60 degrees, and I know that the radius equals 5. And I don't want to fall for it, plug in 60 for my theta, right? That's not correct. They want us to make that mistake, but we are going to convert 60 degrees to radians. And that's, after we convert that, that's the number we're going to put in for theta. Okay, so 60 over 180 equals theta over pi. And we can reduce 6 over 18. Oh, we can reduce again. 1 over 3. And we'll get 1/3 equals theta over pi. And our last step to get theta, we're going to multiply both sides by pi, and we get theta equals pi over 3 radians. Okay. Now 60 degrees is a nice unit circle value. And when I say nice, I mean it's on the unit circle. And so you might even know immediately that 60 degrees is the same as pi over 3. And if that's where you're at, that's great, okay? Because the more quickly we can convert between radians and degrees, the faster we're able to answer some of these questions, okay? So now that I have my angle in radians and I have my radius, I'm going to plug pi over 3 in for theta and 5 in for r. So I'll get my area as 1/2 times pi over 3 times 5 squared. All right, let's see what this breaks down to. Pi over 6 times 25, which gives me 25 pi over 6. And since we're looking at the area of a slice, we want to have the proper units. So it's not centimeters, but centimeters squared for area. And so there is my area of the sector, or area of the slice, that corresponds to a central angle of 60 degrees and a radius of 5 centimeters. Okay? So hopefully that will help you finish up the last 2 questions on the quiz, and make sure that you're looking out for, is the angle given to you in radians, and do they give you the